This is day 6. Today we're going to talk about arc length and circumference. And they are closely related because the circumference is just the distance all the way around a circle. Imagine that you took a piece of string and laid it out completely around the circle. If you stretch that string out straight and measured it with a ruler, the length that you would find, that would be the circumference. It's measured in inches, centimeters, meters, things like that, not degrees. If we're talking about degrees, that's the arc measure. Okay? So that's the circumference is the whole circle. And arc length is a portion of the circumference. Okay, so we've been dealing with degrees, but now we're moving into dealing with centimeters, inches, things like that. Formulas. It turns out that if you know the radius of a circle, you can find the circumference. It's going to be 2 pi r, 2 times pi times the radius. Of course, pi is about 3.14, but it's better to use pi itself. Will be on your calculator. So just use pi instead of rounding so much. Since a diameter is just 2 radii, you see the 2r here in the formula. So it makes sense that another way I could write the circumference formula is pi d. So if you're given the diameter, we'll use this formula. Circumference is pi d. If we're given only the radius, then we'll use this formula. Circumference is 2 pi r. But they both mean the same thing. Okay, let's look at these problems. Look at problem number 1, my friends. Find the circumference. Well, I just told you that the formula for circumference is, and we're given the radius, so 2 pi r. So in this case, the circumference is going to be 2 pi times 8. So that circumference is going to be 16 pi. So that would be our exact answer, is 16 pi. If you needed a decimal for some reason, then you could just put that in your calculator. Using your TI-30XS multi-view, you will notice that the pi button is right here. So if you want to do 16 pi, then there it is. So if I hit enter, well, toggle, then that's approximately 50 point, I'll use 2 decimal places, so 50.27. Okay? Feet in this particular case. All right? This form with the pi in it is exact. So if you ever see the directions say, well, give me the exact answer, they're meaning none of this 3.14 business, no rounding with a decimal, leave pi in your answer, so there's no rounding, it is exact. Okay, number 2, find the circumference. The circumference is 2 times pi times the radius. So I could divide this 13 in half to get the radius, but it's easier to remember that the circumference is also pi times the diameter, because that is 2 radii. And the diameter is 13, so the circumference is, think pi times 13, but it's more comfortable to write 13 pi. So that is the exact answer. Or we could get the decimal version of that, which would be 40.84 inches. Okay, so the exact answer and the decimal. Be prepared to give either one. This time we're given decimals right from the beginning, so we will definitely use decimals. So find the radius. All right, so we kind of have to work backwards. You see that radius shows up in this formula. So circumference is 2 pi r. We're looking for r. we are given the circumference. So I can just take this circumference and put it here in for C. So this becomes 65.98 is equal to 2 pi r. Now I just need to solve this for r, and I could get r by itself by dividing both sides by 2 pi, like this. Just divide by 2 pi. These cancel out. So that tells me what r is. So 65.98 divided by 2 pi. 65.98 over 2 pi. Kabam! I'm getting 10.50. So that's what it is. Okay, so r is 10.5 centimeters. All right, that is how you do that. Let's keep going. Look at number 4. Find the indicated measure. We want the exact radius of a circle with circumference 42 meters. All right, well, we're going to do this the same way as we did the last problem where we had to find the radius, but this time no decimals because it says exact. So again, the circumference, one formula for the circumference is 2 pi r. We're supposed to find the radius, so that means we're looking for r. But they gave us the circumference is 42. So I can just take this 42 and put it in where it goes for circumference. Okay, so that means 42 is going to equal 2 pi r. So, like I said, we want to get r by itself, so we can just divide both sides by 2 pi. These all cancel out. So then it's just a matter of simplifying this. Now, I'm curious what the calculator will give me. Now, it says exact, so I don't want any decimals. But what will the calculator do if I put 42 over 2 pi? I don't actually know at this moment. Okay, it goes straight to the decimal. So that's not going to be what I want. So I'm going to have to actually use my brain a little bit. 42 over 2. If I kind of take the pi part out of it and focus on that for a minute. Okay, look at the part right here where I have 42 over 2. What is 42 divided by 2? Yeah, that's 21. So if I basically reduce this fraction and divide by 2 in the numerator and the denominator, then I'm going to get r is equal to 21 over pi. And we have to leave it like that because they said exact answer. All right, so all I did was divide the top and bottom by 2. 2 divided by 2, that's 1, so that's why the 2 went away. 42 divided by 2 is 21. Okay, number 5. Again, we are looking for the exact answer. So, the exact diameter of a circle with circumference 39. This time they said diameter. Remember that another version of the circumference formula is circumference equals pi d, pi times diameter. Since they're asking me for the diameter, it will be easier to use that formula, that version. So let's do that. Circumference equals pi times diameter. But since they gave me the circumference of 39, there's no reason why I can't put that in there. So that's going to give me 39 is equal to pi times the diameter. Now I'm supposed to be finding this diameter. So that just means I need to divide both sides by pi to get d by itself. So these pi's cancel each other out, and look, that's the answer right there. Diameter is equal to 39 over pi. Okay, they said exact, so no decimals. Let's go ahead and do number 6. Find the exact circumference of a circle with diameter 15. There's that word diameter again. So once again, let's go ahead and use the version of the formula that involves diameter. Circumference is pi times diameter. Okay, diameter is 15, so we can definitely go ahead and take this 15 and put it in for diameter. So this will become circumference is equal to pi times 15, right? Wow, okay, this is a really easy problem, but we'll just go ahead and write it as 15 pi, because that is more traditional. But that's the answer. We just plug, that's all there is to it. It's so simple it makes me stutter. All right, number 7, the exact circumference of a circle with radius 27. So this time they're mentioning radius. So let's go back to this version of circumference. 2 pi times the radius. The radius is 27 feet, which means we can take this 27 and put it in for the radius. So that becomes circumference is 2 pi times 27. So that comes out to be 54 pi. Okay, again, it says exact, so no decimals. Just 2 times 27 is 54. Okay. All right, now we're moving on to a different phase of this lesson, finding the length of an arc. All right, well, an arc is a portion of the circumference. So if I want the length of arc AB, I'm trying to find the length of this piece right here. All right, the length, not the degrees, 60 degrees, yes, but that's not what we want. We want how many centimeters this is if we were to measure it. Now, the key is this. Everything is going to boil down to part over whole equals part over whole. I want you to absorb this. So we're going to do two different kinds of part over whole. We have degrees, which we've been working with. So the partial degrees, you know, the degree measure of the arc will go in the top, and then the total degrees will always be 360. So part over whole degrees, the arc measure divided by 360, will be 1/2 of this equation. On the left side, I'm going to do part over whole again, but this time it will be length. All right, the arc length will be the partial length, and the circumference, well, that's the entire length. So part over whole equals part over whole. Length on the left, degrees on the right. That is what we're about to do. Okay. So just to write a memo to ourselves, we are doing part over whole equals part over whole. On this side, we're doing degrees, and on this side, we're doing length. Okay, let's get the degree part out of the way because that is the easiest. So part over whole degrees. The partial degrees here are 60. The total degrees, all the degrees in a circle, are 360. All right, so that's part over whole degrees. Now, part over whole length. Well, the partial length, we don't know. That's what we're supposed to find. That was a terrible X. Let me try that again. So pretty. So the partial length, that's what we're trying to find. That's X. Now the total length is the circumference. And I like to calculate that off to the side somewhere. Let me change colors because this is like a side calculation. We're finding the circumference because that's what goes down here, the total, the whole. Circumference is 2 pi times the radius. So in this case, the circumference is 2 pi times 6. So the circumference is 12 pi. Okay, so that 12 pi is the whole length. The circumference is the whole length. So this is the equation that we have to solve. Now, what I would recommend to you is reduce this first. Okay, what do they say? Reduce, reuse, recycle? Well, we're definitely going to reduce. So in our TI-30, excess multi-view. If we do 60 over 360, you will see that that is 1/6. Okay, so what we have here is x over 12 pi is equal to 1/6. So basically we are just going to cross multiply. Okay, is the general what we're going to do. So cross multiply. So the 6 times the x, okay, as we do this diagonal, okay, we'll have 6x. And then as I do the other diagonal, okay, 12 pi times 1 is just 12 pi. So we cross multiply, we have this. Now we're looking for x, so we're going to go ahead and divide by 6 on both sides, like this. Okay, so that is going to give us x equals, 6 goes into 12 twice, so that's going to be 2 pi. All right, so that's actually the exact answer, is 2 pi. You could put that in your calculator, and you would get 6.3. And we should not leave off the units. This is centimeters. All right, so 6.3 centimeters, 2 pi centimeters. That is how you do that. Okay, so whenever they're asking you for arc length, think part over whole equals part over whole. Let's do it again. Part over whole. So once again, on the right hand side we will do degrees. All right, so we are trying to find this arc length x. But first the degrees. The partial degrees are 150. The total degrees are 360. So that's part over whole. Now we'll do part over whole length. The partial length is x. The total length is the circumference. So we will again calculate the circumference off to the side. 2 pi r. So that's 2 pi times 18. 2 times 18 is 36, so that's 36 pi. So that is the circumference. That's the whole length of the entire circle. So when I do partial length over the whole length, the circumference goes here as the whole. Like I said, you should always reduce this before you do anything else. Reduce. 150 over 360. 150 over 360. Okay, that's 5 over 12. Okay, so that means we have x over 36 pi is equal to 5 over 12. Time to cross multiply. So if you cross multiply, we've got the, I want to change color. So if we do the 12 times x, all right, that's 12x. And then if we do 5 times 36 pi, I'm just going to do 5 times 36 because I know it will be pi. I don't want any decimals. So 5 times 36 is 180. Okay, so this will be 180 pi. All right, no decimals until the end. If you already have decimals, you messed up. Go back and do it the way I'm trying to show you. All right, if you're going to get a decimal, I want it to be at the very last step, not in the middle of the problem. Too much error occurs if you do it that way. Okay, so 180 divided by 12. Curious what that is. That's 15. Well, that's very nice. Okay, so that's, the pi will still be there, but this will be 15 pi, okay, inches. So that is the exact answer. Okay, or as a decimal, that would be 47.1 inches. So there's that. All right. Number 10. Once again, we are going to do part over whole equals part over whole. And once again, on the right hand side, we are going to do degrees. The partial degrees is 30. And of course, the whole is 360 degrees. Let's put a little divider here. Now on the left, we're going to do part over whole length. Of course, the length we don't know, so that's going to be x. Now the whole, that's the circumference. Okay, so that circumference is 2 pi times the radius. So this is 2 pi times 28. That's the whole, it's the circumference. So let's go ahead and simplify this. 30 over 360. Hi there, sweetie.
Are you talking to your kids?
I am talking to my kids. You're in the...
Remind me.
Say again?
Remind me. I'm sorry.
Oh, don't mind you. Are you okay? My kids might get a kick out of hearing your voice on the video. Why don't you come say hi?
Hi.
Yeah, I mean, obviously they can't answer back because I'm just recording a video. Say something. Tell them something about who you are or anything.
I'm Maya. I'm your teacher's daughter. And I just came down, so he told me to say hi.
That was pretty good. Thank you very much. Alright, so I told you to reduce this side. So this side is going to reduce down to 1/12. This side, alright, 2 times 28 is 56. So this is going to be 56 pi. And then you cross multiply. Doing this diagonal is going to give us 12x. And of course 56 pi times 1 is just 56 pi. So if we just divide both sides by 12, alright, this is going to give us the answer. This will reduce a little, so put 56 divided by 12 in your calculator. My TI-30XS multi-view tells me that 56 over 12 reduces to 14 over 3, and that pi will still be there. So this is the exact answer. X, the arc length, is 14 pi over 3. As a decimal, let's see, 14 pi over 3, toggle it, that's 14.66. And we should not forget the units, which are feet. Okay, that is how you do number 10. Now, these last three are slightly different. We're still going to use part over whole equals part over whole. But in these cases, unlike the last three problems where we were being asked to find the arc length every time, arc length, arc length, arc length, which was always this upper left-hand variable when we do part over whole. For these problems, we're being asked for different things. For this one, we're being asked for the arc measure. Right? Remember, that's degrees. So on the last time I gave this test, when we had a problem just like this on the test, my kids would see this 23.88 here on the arc. And then they'd see that here I'm asking for the measure of arc AB. And they'd say to me, but Mr. Burton, it's already, isn't it just 23.88? Isn't it already given? No. This little m means that you're being asked for the arc measure. That's like how many degrees this is. Like, so let's estimate that. you know that like 90 degrees, okay, if I did like this, that would be about 90 degrees. So widening that out, okay, this arc is clearly something bigger than 90 degrees. So this might be 100 degrees or something like that. So just as a rough estimate, the thing that we're being asked to find is the measure of this arc, which should be something around 100 degrees. This 23.88 that we're given is a length. See the inches. It's what you would get if you took a piece of yarn and you stretched it out along this edge and then you straightened it out and measured it. So we're given the length, but we're being asked for the degrees, the measure. And as far as part over whole equals part over whole, the partial degrees are this right here, okay? You know what I mean? So basically we're being asked for this angle right here. This is our unknown for this problem. I should erase that. Okay. Okay, so that's the key. So we're going to do part over whole equals part over whole like this. Part over whole equals part over whole. Alright, but this time when I do my part over whole, okay, when I go to do partial degrees over total degrees, I know the total degrees are 360. Now the partial degrees, that's what we are being asked to find, you know, because the arc measure and this angle are the same thing. So we are being asked for this. So that means we must be given everything else. So this is the partial length, and we are given the partial length, 23.88. So the 23.88 goes here, part over whole, partial length over the whole length. Now, of course, the whole length is known as the circumference of the circle, and the circumference is 2 pi r. So this is the circumference, 2 pi times 12. Okay? Normally this is the point where I would like reduce this or something. But, you know, we have this theta, nothing I can do with that. So I've got theta over 360 equals 23.88. 2 times 12 is 24, so this will be 24 pi. Alright, now I've got these decimals and everything, so I'm pretty much going to be stuck with a decimal. But I would like to wait until the last possible second to make a decimal. Alright, so this is what I'm going to do. You know, I could cross multiply right now, okay? And if I cross, maybe I'll just stick to that. Okay, I'm just going to cross multiply. So, cross multiplying, I have this. I have 23.88 times 360, okay, that's this diagonal, should equal 24 pi times theta. That's this diagonal. Now, I'm trying to get this theta by itself. I'm trying to find this angle. So I'm going to go ahead and divide both sides by 24 pi. Okay, 24 pi. So I'm going to divide all of this by 24 pi. So these are going to cancel out. Now the reason why I haven't multiplied these together yet is because I'm just afraid. I'm going to get a decimal that I have to round, and I don't want to round anything until the very end. So I'm just going to leave all my calculations till the very last step. Okay, so this is going to be theta equals. Now you could just put all this in your calculator. Alright, so we can just type all this into the calculator. Just start with the fraction button, and so we've got 23.88 times 360 over 24 pi. Just type it all in. So that gives us 114.02. Okay, so we really cannot get an exact answer because of the decimals that were already there. So this is the best we can do. And this is degrees. All right, we were finding the measure of this angle or the measure of this arc. Either way, it is degrees. So that is what is happening on problem number 17. Now, problem number 18 is its own problem. It's slightly different. So each of these, we really have to look at what we are being asked to find. So we see we have arc length and all this good stuff. So once again, we are going to be looking at part over whole equals part over whole. All right, let's look at what we have and what we don't have. Normally on the right hand side, we do partial degrees divided by total degrees. So let's see, do we have partial degrees? Do we have total degrees? Well, yes we do. The partial degrees are 290 degrees. Alright, we're looking at this major arc. Oh, you know what, that made me curious about something. Remember we sort of predicted that this would be about 100? I'm just looking at it, estimating to see if our answer is reasonable. And here it came out to be 114 degrees. So that's pretty close to our guess. So that tells us our answer is reasonable. So you should always kind of ask yourself, is your answer reasonable?
Maya, did you take your pills?
Alright, apparently Amaya did take her pill, so everything is okay. So this is 290 degrees out of a total of 360. So we have the we do have the partial degrees and the total degrees. Now let's see what we have on this side. On this side is where we do length. So we're gonna have partial length and then the total length or the circumference. We have the partial length, you know, the arc length right here. It is 46.75. So the only thing that we're missing is the whole length, which is also known as the circumference. So I might as well just go ahead and put a big C there for circumference. Now's a good time for me to look back and see what are we actually being asked to find. Well, oh look, we're being asked to find the circumference. And so all we have to do is find the C and we're done. I really recommend using theta if you're finding degrees, using C if you're finding the circumference, and you can use X if you're finding like the arc length, but that will help you keep track of what you're doing. Let's reduce this like I'm always saying. So 290 over 360. 290 over 360. That's 29 over 36. Okay, that wasn't much of a help, but it's something. Basically we cross out those zeros. So anyway, we have 46.75 over the circumference is equal to 29 over 36. Time to cross multiply. Okay, so we're going to do this action right here, and that's going to give us 29C equals, and then we're going to do this action right here. Okay, and you know what? I'm going to do like I did before, and I'm just going to leave this separate. So 36 times 46.75. Okay, now let's see. I'm kind of curious what would have happened if I had multiplied those together. 36 times, what was it? 46.75. Well, that's not too bad. 36 times 46.75, so 1,683. That's pretty good. I'm going to go with that. $1,683. Let's go ahead and divide both sides by 29. Okay, divided by 29, back to the calculator. I'll just hit divided by 29. So that is 58.03. Alright, and I should include the units here, which are feet. So we were supposed to find the circumference, and we did it. Okay, so that is how you do number 18. Now, number 19 is sort of the trickiest one on the paper because it's going to take more than one step to do it. Now, as soon as you see this arc length happening, your instinct should be telling you we're probably going to use part over whole equals part over whole, like we have done on all of these problems. So let's just start setting it up and see what we have and what we don't have. So let's do this. So part over whole. On this side, on the right, we normally do part over whole degrees. Do we have that? Well, you see the 55. So that's partial degrees, and the total degrees are always 360. Alright, so we have that. On the left side, we usually do length. So partial length divided by the total length. Do we have either one of these? Well, yes, we do. We have the partial length, the arc length of 19.71. So that would go here, the partial length, 19.71. Now, what goes here is the whole length, also known as the circumference. I'm just going to put a big C here. Again, don't just put X. If you put X and you find it, you're going to forget and you're going to think that that's the final answer, and it isn't. Because unlike the last problem where we were being asked to find the circumference, so when we found the circumference, we went, yay, we're done. On this problem, we are being asked to find the radius. Now, the good news is, once we find the circumference, finding the radius should be pretty easy. But we will not be done when we find the circumference, so do not stop. So don't use X. So let's cross multiply. First, let's reduce this. 55 over 360. Okay, 55 over 360. That's 11 over 72. Let's use that. No, you guys are okay. You don't have to be totally silent. This is my time, students at school. You in my house, okay? If there's chickens clucking in the background, yeah, that's right. My little girl's playing Minecraft. I'm not going to tell you what my wife is doing, but you might hear some chickens or zombies, or you're not going to hear the creepers because they don't make any noise, except for boom.
Or psst, psst.
Yeah, because they sizzle. Yeah, so no, I'm not going to shush my family. My family can talk. My family can play. And it will just have to be on the video. And you all have to deal with it. You know why? Because it's 7 o'clock at night. And I'm doing schoolwork.
And my daddy is crazy.
That is true. Very true. Let me be clear. It is very important that we get to the bottom of this problem. So, like I was saying before I lost my head, 19.71 over C. What was I saying? Yeah, we will find C, but we won't be done. So let's cross multiply. So if we do that, C times 11, that's 11C. Now, 72 times 19.71. Let's see if that makes a nice number that we can work with. 72. Oh, whoops, wrong thing. I meant to do this. Okay, so let's see. 72 times 19.71. Let's see what we get. Alright. 1,419.12. We can work with that. Okay. So, clearly we need to divide both sides by 11. Whoops, I want to use purple. Divide by 11. Divide by 11. Okay, so I'm going to go back to the calculator. The number's already there, so we can just hit divided by 11. Alright, it does it, so just trust me. So that is 129.01. 129.01. Now, remember, this is not the answer. This is something very useful. I'm going to put a circle around it, but I'm not going to put a box around it. Because we need the radius. Okay? Well, we have the circumference, we need the radius. How are we going to do that? Well, the good news is we've already done that. Let's look at some of the other problems that we've done. Look back at problem number 3, earlier in this same lesson. Look what we had. We had the circumference, and we had to find the radius. How did we do it? Well, we used the formula, c equals 2 pi r. We took the circumference, we put it in the formula, and we divided to find the r. So that is what we're going to do. So, just like we did on problem number 3, we're going to use the formula c equals 2 pi r. But we're going to take this circumference and we're going to substitute it in. So we're going to have 129.01 equals 2 pi r. See that r? That's the radius that we wanted. So if we just divide both sides by 2 pi, we should have our answer. So divide by 2 pi. Okay, all this cancels out. Okay, divided by 2 pi. And you know what? If we look in the calculator, this number is still there. So I really don't even have to round it. Like I just put 0.01 here, but I really like all those decimals. So let's just go ahead and do divided by, okay, that didn't work out so well. You know what? I'm just going to type it in. 129.01 divided by 2 pi. And I'm going to get 20.53. That is the radius. Okay, so the radius was 20.53. And I should put the units centimeters. Alright, but that is the answer. Alright, it just occurred to me something that I need to point out to you guys. Just then, when I put this in my calculator, alright, I was very careful to type this in as a fraction with a numerator and denominator, just like this. I did not want to use this division sign. And I just remember that that's a common mistake that students make. Notice the answer is 20.53. Now let's look back and see what would have happened if I did 129.01 divided by 2 pi without making it a fraction like this. Okay, watch this. 129.01 divided by 2 pi. Oh, look, 202.6. That is completely different than what we got when we did it as a fraction. So why is that? Well, the reason why is because of the order of operations. Your calculator is just dividing by 2, and then it's actually multiplying by pi. So just be careful. My advice to you is, if you want to divide by something, always use the fraction button. Always make it a fraction when you divide. It always will work out correctly. Some kids don't take that advice. If you want to use the division key like this, then you have to use parentheses. That way the pi will be included. So you have to do like this. If you, whoops, wrong. If you want to divide by 2 pi using the division sign, you have to put the 2 pi in parentheses. Now it's dividing by the 2 and the pi instead of just the 2. And you see we will get the same 20.53 that we're supposed to get. So please, I hope you didn't space out too much. I know this is a long video, but that is a common mistake that kids make. See this right here? Don't do this. If you're going to use a division sign with something with more than one part to it, you have to put it in parentheses. But again, Mr. Burton recommends always using fraction mode. Alright, I hope this long video has been worth it, worth your time. I kind of hope that you fast forwarded and just skipped to the parts that you needed. If you appreciate this video, please show your appreciation by hitting that like button. Give me a quick thumbs up, and I will appreciate you right back. In the meantime, I will see you on the next video.